We have done this for years, and Dave was a very logical choice to get this award. Dave is currently the president at AET, and he used to work for MnDOT, obviously. He was geotechnical engineer, worked a lot in research, specializing in concrete pavements, etc. So with that, Dave, you want to take it away?
Sure.
Let's welcome Dave.
Thank you. It's an honor to be here. I did not put a whole lot about Jerry in this presentation, and the reason being, as Glenn sort of brought up, I became a blubbering idiot at his going away party, and I'm almost there already, so I purposefully didn't include a whole lot. But this is the only time, first and probably last time in my life, that I'll have the word distinguished attached to my name. So I wore a tie in honor of that. But I would like to just say a couple things about Jerry. My presentation actually just is focusing on research and implementation. Jerry was, as Glenn said, a great guy. The real strength of Jerry wasn't his technical skill. His real strength was his leadership and his interpersonal skills. Jerry was a guy who would open doors for us to get things accomplished. What I'm going to go over here is how a lot of the achievements, things that happened while Jerry was at MnDOT in research, we were able to do a lot of things. Glenn and I inherited the Min Road project the day after it was open. And until that time, the focus was strictly on getting it built, and then we had to figure out what to do with it. And it was it was a challenge. A little bit about me. This ties into our previous presentation, actually. My first introduction to pavement engineering was at the University of Minnesota with a class I took from Gene Skoke. I'm sure a lot of you who had Gene as an instructor had the same experience. I had a light bulb go off, and I was somewhat hooked on that ever since. And then immediately thereafter, I got a job working at MnDOT as an intern. Worked for a gentleman by the name of George Cochran, who another great individual, smartest guy I ever knew. Knew more about pavements than anybody. And one of the great things about George was the more he knew, the more he was convinced he didn't know. So he was never comfortable because he always knew there was more information out there that he could make a better decision with. But I started testing highways with the falling weight deflectometer in 1984. And I drove all over the state. Our goal was to hit every flexible pavement in the state on a 4-year cycle. And we did do that, and we used that data an awful lot for pavement rehabilitation and pavement design back in the 80s. At that time, the state of the art for pavement analysis was a MnDOT TON program. That program was based on Investigation 603, which was a Binkelman beam. That's a picture of a Binkelman beam. They actually still do make them today. I don't know if there's still one in the lab mezzanine or not, but we kept one for posterity. So that study was completed in 1967. So 34 years later, state of the practice for pavement strength testing is still the FWD. State of the practice for pavement analysis at MnDOT is TON 2010. Still based on Investigation 603. It was updated around 2010, but we're still using that old study. We now collect all this data with a state-of-the-art piece of equipment that collects deflection at 7 to as many as 9 points, and then we relate it all back to that 1 point still. So we've come a long way in 34 years. That being said, as I said, Glenn and I got into research back in 1994. We wound up at Minroad at the same time. MnDOT's always been a leader in pavement research. We were very proud of that. We always have been. Everyone we always talked to told us how lucky we were to work at a place like that was so committed to research. We started laying the groundwork to move into mechanistic design back in the 80s. With the FWD, with some other studies, we had spring recovery test sections that I started testing again in 1984, weekly and bi-weekly in the spring for putting spring load restrictions on. And then we hit those at least once a month all summer and into the fall. And we did that on these sections for, into the mid-90s at least. So we were collecting the data to move to mechanistic design, and we had improved information over but we were going to take it from the 603 study. But then we built Minroad, and that kind of moved by the wayside a little bit. We also started testing soil in the laboratory in the 1980s with a interlocking universal testing machine. So we were running resilient modulus on soil and base materials back then, again, with the eye towards mechanistic design. The 86 AASHTO design guide started pushing us in that direction, and then the 93 revision was really the first step in the next step to the 2002 design guide, which took a little longer than 2002 to actually turn out, but we started moving along that path, again, with the idea we were going to quit running R values, we were going to use mechanistic methods. The 1990s, in my personal opinion, was the golden age for MnDOT in the pavement design and materials area. We had this list of distinguished people there in no particular order. George Cochran, Dwayne Young, Doug Schwartz, Jerry Rohrbach, Mike Robinson, Joe Mead, Roger Olson, Dick Sullivan, who was the head of materials and road research when we opened Minroad. Another guy who said, okay, now we got this beast, what are we going to do with it? And Terry Zoller, who was my boss in the concrete office. And then at the University of Minnesota, we had Mark Snyder and Dave Newcomb at the same time. Hard to believe you could get two guys that, I'll use the word distinguished. All right, look at that. I didn't touch a thing. You just click it off?
Yeah.
All right. At the university at the same time, the research program we were able to put together, the graduate students they were turning out, it was phenomenal. And we have, I don't know, there's got to be 20 graduate students who came out of that program at that time that are still working at MnDOT. Several of them are still in research, but a number of them are scattered throughout the department. And really, they put out some top-notch people, and a lot of them are in leadership positions at the DOT now. At that time, we also had the really good fortune of having an assistant commissioner by the name of Dave Eckern, who was really a proponent of research implementation. And that was really the key to a lot of the things that were accomplished in the 90s into the early 2000s. Having a leader like that on board who was committed to using what we got out of Minroad and other research that we did, getting it implemented, not worrying about fallout. We had to have a plan. We had to be rational about what we did, but his rationale was, what's the downside if it fails? Don't let the risk scare you, just have a backup plan if you have to. So some of the things we were able to accomplish at that time, we put a concrete white topping on Minroad on I-94, which if you would have been at the meeting when that happened, We had predictions that it was going to last for weeks and that we'd have to close Min Road down. It was a very interesting time because the decision was made and it actually worked out quite well. But had we not had some strong leadership at the department at that time who was committed to research, it never would have happened. And from that, the BCOA concrete, bonded concrete overlay program was developed. So again, that early commitment is still bearing fruit. All right, so there we go. Other things that happened in the 1990s, the MnDOT Geotechnical and Pavement Manual got updated. Dwayne Young did a phenomenal job rewriting that. He led the effort. That really is a textbook. Everybody should get a copy of that if you're interested in pavement design, because it's possibly, in my mind, if you work in the upper Midwest, at least, it's the best piece of literature available for designing and constructing pavements. We did super pave implementation. I'm going to pick on Doug Schwartz. So my previous list here is, I'm going to embarrass people because I see Doug in the audience here, but Doug was both the bituminous and the concrete engineer at different times, however. But he was responsible for more change than any individual at MnDOT in the last 40 years. Super pave was implemented under Doug. That improved the asphalt binders that we use, made a huge improvement on the aggregate gradations and the aggregate quality that went into the asphalt. Prior to that, we were getting very sandy mixes with relatively low binder contents. We had a lot of stripping and rutting issues. Implementation of super pave, which did not come easily, was not well received by industry at the start, but Doug held his ground, and again, he got support from several of the people on that list, and our asphalt pavements are all the better because of it. Then, because Doug had been beaten up so bad, he decided he wanted to become the concrete engineer. He had worked there before he became the bituminous engineer. He was the assistant concrete engineer. And then went about doing much the same thing when he was over there. At that time, our concrete mix design, which was done by MnDOT, consisted of 530 pounds of cementitious material, generally 450 pounds of cement, 80 pounds of fly ash, 1,200 pounds of sand, and rock to fill in the rest. And that was the mix design. And whatever water ended up getting used, it was supposed to be a 0.47 water cement ratio, but we learned that we were getting well into the 0.5, 0.52 range. So, and we had some performance related problems because of it. So Doug started looking at getting the water cement ratio down, dropped it down to a 0.4, huge improvement on quality. And we were looking at things at the time, the bridge spec was 0.44, so why weren't we at least putting as good a concrete in the pavements as we were putting in the bridges? We started allowing a higher cementitious substitution. Up until that time, it was 15%, no more. We could go up to 25%, or excuse me, 20% in the fall, but it was a 4-for-3 substitution, so it was still 450 pounds of cement, but we could increase the amount of fly ash a little bit. And that was just to pick the strength up. It had nothing to do with the durability or anything like that. So we started boosting that up to 25%, 30%, looked at using ground granulated blast furnace slags, started looking at ternary blends. A lot of complications to our what had been a very vanilla mix design, all done for improving the quality. Then we also improved the aggregate quality and the gradation, which helped both get the water cement ratio down, but also improve the durability. So that all happened in about a 10-year period. a lot of change at MnDOT. The nice thing was both things happened simultaneously with bituminous and concrete, because one of the reasons that, in my opinion, the quality had gone down so far was there was a lot of pressure to lower the price of both materials so that they'd be competitive with each other. What happened now with the improving the quality was we were able to offset the added cost on both materials simultaneously, and at least neither side fought as hard about the increased price because it was happening to both at the same time. We also had quality issues arise at the same time in both materials, so the resistance was also reduced somewhat. And another thing that happened in the 90s was contractor quality control, quality assurance. The contractors prior to that really weren't responsible for their own QC. MnDOT took care of everything. This change making them responsible for all their own mix designs, all their own testing, getting all their mixes approved, all the quality control tests at the plants, made them responsible for the quality of their own material, and in the end improved the quality significantly over what we were getting before. Even though we were doing all this plant inspection, we weren't really getting the benefit of the manpower. So then, like I said, Glenn and I inherited Minroad. It was built in 1992, so we were doing all this research beforehand. We had, as I said, a commitment to research. There was a group at the lab and pushed for a big world-class research center, which became Minroad. It was built from 92 to 94. It was funded primarily by MnDOT itself. And we were looking really at doing research centered on MnDOT. What are our needs and what are we going to get from this? We hired some world-class experts to help in the design, Dave Newcomb, Matt Witzak, Mark Snyder, and others. Then we opened it. And right away what we found out was we had so much instrumentation and so much data that it was really a monster, and it really became a data handling problem more than a research program. Luckily, as sensors died, that helped to solve itself somewhat. Then we also had the other problem of that week of 40-degree below zero weather in the winter, and our mechanistic design experiment kind of went by the wayside because we started picking up cracks in the asphalt every 4 to 6 feet. So your homogeneous continuous layer for modeling disappeared. We had to figure out some other things to do with it. At the same time, we also figured out that the cost of operating and doing all this research was going to be staggering. And like I said, we had focused so hard on getting it built that we didn't give a whole lot of thought to, okay, now that we have it, what are we going to do with it? So early on, like I say, Dick Sullivan was the guy who told Glenn and I that we got to figure out how we're going to pay for this puppy, because this is going to cost a lot, and we got to find some partners. And we were able to support an extremely large graduate student program at the U of M through the project. But when we started looking at for partners, the first thing we heard was, it was all built with your materials, it's not applicable to us. And the second thing is, why would we need to partner with you? We know you guys got to publish or you're going to lose your jobs, so we'll just wait for the reports to come out. And unfortunately, both were correct. So between the size and the daunting funding issues, we also lost focus on all the other research we had going on, because basically at that point we had Minroad, which took up about 70% of our research program and staff. And then our other projects, which were the non-Minroad projects. And we never really did a good job of tying Minroad and non-Minroad together, which really would have been much more successful. And we were able to start doing that later, but again, we had such a focus on Minroad that it became a distraction. But we were able to make a lot of interesting implementation in the short term. We did some things with concrete. Again, the water cement ratio, things like that were done non-min road. Super pave was done non-min road. Unfortunately, everything that was paved up there wasn't super pave, which again, down the road became a little bit of an issue. Because it was constructed prior to all those changes, a lot of what we were learning up there from a material standpoint was no longer applicable because super pave wasn't up there. All this low water cement ratio, higher quality material wasn't up there. But we did build it to the real world standards that we had at the time. We had all the same mistakes that happen in regular construction. There's one concrete test section that the paver broke down in, and they were throwing 5-gallon pails of water on it to finish. We had to keep it in place because we had probably $150,000 of instrumentation in the thing, and we weren't going to get new instrumentation to replace it, and lo and behold, that thing is still out there. So just like the real world. Excuse me. Some of the things we do know is the mechanistic pavement performance data is still valid and it is being used. Last year, Julie Vandenbush was the Rohrbach speaker, and she truly is distinguished. She said that 85% of the research she does at Pitt contains min-road data, which tells you the value of the program. Even though we had our flaws, it's still, what Glenn and I used to say is it may not be perfect, but it's the best one we got. So, min-road now. I'm really excited about the new focus. I think the NRA format is really what was needed to get outside interest. This new approach of getting the partners involved, drumming up a lot of partners, which we've done a really good job of because we did it before we built instead of after. And really focusing on the needs of the many, not being parochial to Minnesota. We've got a lot of interest and a lot of very actively involved partners, which is a great thing to see. We have very frequent meetings, so frequent that I'm unable to attend the bulk of them. But it is great to have so many people who do, and that the chairs of the committees are not from Minnesota necessarily. They're from all the partners, and the members of the committees are from all the partners. So the success of this next phase of construction at Minroad, I think, is really strong because of that. Again, focusing on the implementation. So to me, the challenge is moving forward as we focus on this. I don't want to forget the past. When we write new specs and manuals, there's a lot of information out there that can get lost when we do major rewrites, especially in the manuals. There's a lot of instruction that's in those that when you do major editing can be lost. I'd like you to look at the 2 iteration ago pavement design manual and compare it to the current one. The current one is very applicable to the pavement design methods we use now, but it doesn't have the instruction and the information I think that the old one had. So if you can get your hands on both, I think the 2 together are really good tools. And I don't want you to forget the construction aspects when related to pavement performance. One thing we can do is improve our specifications, we can improve our materials, we can improve our pavement design processes, but we got to get the construction aspects figured in, because if they build them the same way, all those other aspects that affect performance are still going to be there, and you may not get the desired pavement life improvements that you were hoping for. Learned that on our first 60-year pavement design project that we constructed. The contractor started nailing the dowel baskets with the paver right away, and like that didn't factor into our 60-year pavement design. So you do need to include those contractors in how you're going to be implementing your specs. Also, with the contractors, once you can get them on board, it's really important When they see why something's important to them, they'll jump in with both feet. We learned this last year. A prime example, anyway, was the intelligent compaction project. We started working with a few contractors, and they were having some density issues. We went back over their IC data and looked at the speed of their rollers and the amplitude of their vibrators. Showed them what happened with density compared to where those measured factors were, got them to make some adjustments, and lo and behold, the density immediately improved. And now they understand intelligent compaction as a valuable tool. But until it was important to them, it was just another thing you're loading onto us. Extra work, but what's in it for me? Well, now there's a lot in it for them. So in closing, 30 years after starting resilient modulus testing, where are we? We're still running R values, but we're this close to implementing mechanistic. Actually, you can use resilient modulus in MinPave, but we don't have a whole lot of actual data for it. And even though they are based on 50-year-old research, TON 2010 and the 93 AASHTO guide for the design of pavements are still highly applicable. We use these all over the country. We do pavement design projects in 40 states, and a lot of what we work on is for heavy construction, on wind projects, oil field, that type of thing. And we use both of these methods to determine how to build a road that'll last just long enough for the construction. Because they don't want to spend more than they have to. It's not like a state where if it lasts an extra 10 years, great. They only want it to last exactly how long they need it to, because anything more they overpaid for. And these things work extremely well. So we have some amazing tools out there, and we've been able to verify that through application all over the country, which is phenomenal. Never would have thought it to be the case, so I'm really happy. The other thing I want to just remind everyone is implementation is a multi-year process with continued refinements along the way. The research report is not the end product, that's the starting point. You need to really get it implemented and then monitor those changes that you've implemented and document them and refine them continually. And then I think we'll continue to make great progress. All right, so that's what I've got, and amazingly right on time. So. If anyone has any questions, sure, I'll take them. Doug Schwartz is back there. I picked on him a lot.
Uh-oh, the guy, he's the nervous guy back there.
I just want to comment, Dave, to you for all the work you did with various committees, especially with in the concrete area. A lot of the ideas you came up with, replacing after drag, replacing siding, as far as safety issues, and sharing that group of people. I was amongst people working for Dave on Dave's committee back then, and all the good work he did. Need to be complimented on that.
Thanks, Doug. Again, if I didn't have you there to implement things, it wouldn't happen. So.
Anything else? I'm surprised Dave didn't talk about the spring load restriction meeting we had. Remember? We went in and...
Well, that was Dave Eckern again.
Tell that story quick.
You probably remember it better than I, but...
well, at the time, MnDOT was setting spring load restrictions.
Yeah, so the way we used to set spring load restrictions is we'd go out with an FWD and we'd measure test sections that we had, and then we had frost tubes in the road all over the place. And then we'd test these things and look at the frost tubes and test these things and look at the frost tubes and then talk to the maintenance superintendents and then go, what do you think? What do you think? What do you think? All right, now's the time. And invariably, we then had to put out I think it was a week notice before we could actually put them on. So John Siegmeyer, Dave Van Dusen worked with me, and they did all the work. And we came up with a method of using all the information that we had available to put on spring load restrictions based on all the FWD data we had and the analysis methods that we had developed. And they came up with a process with thawing degree days and actually including the angle of the sun, and developed an equation that we put together for posting spring load restrictions. The big selling point on it really was we could put a hard date on, we could make a prediction based on weather forecast, be accurate to within a day or two at the worst. But what sold it was the damage caused by being a week late. We had to extend the spring load restrictions by 4 weeks at the end to make up for that damage. So that sold the program really easily, because extending spring load restrictions for 4 weeks into May and June really put a hindrance on the business. And we were able to get that implemented relatively quickly. And then again, Rettner was the guy who drove it home. So it was really a team effort, but research applied, and it's still in place today.
And I remember we were a lot younger then, obviously, and we walked into that meeting, oh, these are all the big wheels, what's going to happen? Boom, it happened within 10 minutes.
Yeah.
Go ahead, how come you guys aren't just doing this? So that was the way you need to implement projects. So Dave, thanks, great talk, and we want to present you with the Gerald Rohrbach Distinguished Service Award.
Oh, thank you.
Thanks. Okay, continue my thank yous. Bob has been faithful. Those of you here yesterday, Bob was our guy running the slides. He's our techie guy doing the marketing, etc. So let's give Bob a hand.